All right, welcome back everybody. My name's Mr. Swaner, and today we're going to talk about multiplying and dividing exponents. Before we begin, make sure that you pick up your companion notes so that you can follow along to this presentation. Let's start with a quick review about what exponents really are. So here I have 2 to the third power. And what that really means, literally that means 2 times itself 3 times. So that literally means 2 times 2 times 2. And to solve this, I'm going to take 2 times 2 and get 4. And then I also need to multiply this last 2 by that. So now I have 4 times 2, which is 8. And let's say, for example, I had 2 to the 5th power. That just means I have 2 times itself 5 times. And I'm just going to take these individually. So I'm going to do 2 times 2 is 4. And now I'm going to multiply that next 2. So now I have 4 times 2. That's 8. And then I need to multiply that by 2 again, which will give me 16. And then finally multiply by that last 2, which will give me 32. So that's just a quick review about what exponents actually truly mean. So let's dive right into some multiplying exponents. So let's say, for example, I have 3 squared times 3 squared. And let's break this down into what it really means before we start using our shortcut. So 3 squared, this red 3 squared here on the left, breaks into 3 times 3. And I'm going to drop down my multiplication. And this other 3 squared means 3 times 3 as well. So now I have 3 times 3 times 3 times 3. Well, I'm going to break this up into a little bit simpler. 3 times 3 is 9 times, and then the purple, 3 times 3 is 9. So now I have 9 times 9, which is 81. So that's the long way about it. But I think this is really important to understand, because if you forget your rule, you can always break down into what this actually means and create the rule for yourself. So let's look at something maybe just a touch harder. So I've got 4 squared times 4 to the third power. I'm going to break this up. So 4 squared breaks into 4 times 4. And I'm going to multiply that by 4 to the third power, which is just 4 times itself 3 times. And then we're going to break this multiplication up to make it easier for ourselves. So I'm going to do 4 times 4 is 16. Then I'm going to take the 4 times 4 over here and make 16. And now I still have this other 4 that needs to be multiplied. So let's go ahead and knock out this 16 times 4 is 64. And remember, because I'm multiplying and I'm only multiplying, I could multiply in any order that I want. I think it's easier to do 16 times 4 than 16 times 16. And lastly, I have to multiply 16 times 64. I'm going to break out my calculator for this one. And 16 times 64 is 1,024. So 4 squared times 4 to the third power is 1,024. So our rule is, and I hope that you notice this, is that all I have to do, if I have the same base and it's being multiplied, I can take the exponents and just add them together. So let's look at a couple using this rule. If I have 5 to the 4th power times 5 to the 3rd power, I can just take those exponents, add them together. 4 plus 3 is 7. So if I had 12 to the 7th power times 12 to the 9th power, I'm going to write as a base 12, and I'm just going to add these exponents. 9 plus 7 is 16. So this is a nice handy little shortcut here. If I've got 91 to the 14th times 91 to the 12th, the rule is the same. It doesn't matter how big your base is. I'm going to use my base, 91, and I'm going to add 14 and 12 to give me 26. Now, if I have 3 to the 9th times 4 to the 3rd, this is an example where I can't use my shortcut because they have different bases. So just be careful that you're only using this shortcut when you have the same bases. That's the only time it works. Well, we can do multiplication with exponents. If we have variables too, all a variable is, well, we don't know what this number is yet, but we can still use that rule. So if I have x squared times x to the 4th, I'm going to write my base x, and I'm going to add my exponents together. 2 plus 4 is 6. Okay, it doesn't matter if I use x or y or r or c, all variables will work. So y to the third power times y to the fifth, I'm going to add that up. 5 and 3 is 8. So that'll give me y to the 8th power. Just to kind of show you here, here is r to the 9th times r to the 5th. 9 plus 5 is 14, so I have r to the 14th. That's about it for multiplying exponents, at least this basic multiplication. So let's talk about dividing exponents. And I'm going to show you the same way. Before I give you the rule, let's talk about what it actually means so that if you do forget the rule, you can always do this the long way and it should give you your rule. So here we go. We have 2 times itself 7 times. That's what 2 to the 7th really means. And then on the bottom, we're going to do 2 to the 4th power. So that's 2 times itself 4 times. And remember, if I have 2 over 2, or any number over the same number, that can cancel out because it just gives me 1. 2 divided by 2 is 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 1. And what I'm left with is my answer. I have 2 times itself 3 times. So if I take 2 to the 7th, divide by 2 to the 4th, I'm left with 2 to the 3rd power. This is the proof. This is the long way around it, but I think this is very helpful. Again, if you forget your rule, you can go through and do this, and it should give you the rule. So let's do 5 to the 10th over 5 to the 4th. So 5 to the 10th means 5 times itself 10 times. You can see why we have a shortcut for this, because this could be a real pain. And then I'm going to do 5 to the 4th down on the bottom. And remember, I said any number over the same number just cancels out to be 1, so it looks like I can cross out 4 of these. And then what I'm left with is my answer. I have 5 times itself 6 times, so my answer is 5 to the 6th. We can do the same thing with variable bases. X to the 4th just means x times itself 4 times. X to the 1st means x once. X over x is the same as 2 over 2 or 10 over 10 or any number over the same number. It still ends up being 1. And what I'm left with, x times itself 3 times, which is x to the 3rd. And our rule is that if you have the same base and you are dividing your exponents, that you can take the exponent from the numerator and subtract the exponent from the denominator. That's the shortcut. As we were going through there, you can literally see why you can do that. You're canceling your exponents from the bottom, and your answer is what is left on the top. So let's use our shortcut. So 7 to the 12th over 7 to the 5th, you can see that I'm going to cancel 5 7s from top and bottom, because I will have 5 on the top and 5 on the bottom that will cancel out. Or we can say, well, I'm just going to take 12 minus 5, and that will give me 7 to the 7th power. Remember, you can always draw these out the long way. So if I had 12 to the 30th, you're probably not going to want to draw that out the long way. So it's good that we know our shortcut, but you should also know that you can do that. But we're going to use our shortcut here. We're going to do 30 minus 10, and that gives me 12 to the 20th power. Huge number. Okay, we could do the same thing with a variable, r to the 50th divided by r to the 25th. I'm going to do 50 minus 25, which will give me r to the 25th. Well, we haven't talked about negative exponents yet, and a negative exponent is kind of tricky, but it's also really simple. So I'm not going to explain why we do this. I'm just going to simply give you the rule. If you have an exponent that is negative, to turn it positive, all you do is move it from whatever place it's in into the other. So in this instance, I have 2 to the negative 3. This is 2 over 1. So 2 to the negative 3 is in the numerator position. I just have to move it to the denominator position to make it positive. So if we look at 5 to the negative 7, that is 1 over 5 to the positive 7th. So to remove that negative exponent, I need to move it from the top to the bottom, or if it's negative in the bottom, I can move it to the top, and I'll show you that in just one second. So if I have x to the negative 10th, this is in the numerator position because this is x over 1 to the negative 10th. And I'm just going to flip it and move it into the denominator position, and that will make it positive. Well, if I have that negative in the denominator position, all I'm going to do is move it up to the top, and this is now 2 to the third over 1. So I can do the same thing. 1 over 5 to the negative 7 is just equal to 5 to the positive 7. And I can do the same thing with an x, 1 over x to the negative 10. To make that positive, I'm just going to flip it out. So it'll just be x to the positive 10. So let's look at a couple of examples here. So I have x to the 4th times x to the negative 2. Well, I don't want to work with a negative exponent, so to get rid of that negative exponent, I'm going to move it down into the denominator position. And now this is just my dividing exponents rule. I have x to the 4 over x to the 2. I'm going to use my shortcut and do 4 minus 2. Leaves me with x squared. Let's look at another here. We have x to the 7th times x to the negative 4. Well, I need to move that negative 4 into the denominator position to make that exponent positive. And now I just have division, so I can do x to the 7 minus 4. Or if you want to draw it out the long way, that's still okay. That's always an option. But I find using the shortcut is much easier. I know that I have 7 on top, 4 on bottom, and 4 of those are going to cancel out, leaving me with x cubed. If I had x squared times x to the negative 6, I've got x squared over x to the positive 6. Remember, I'm moving that negative 6 down into the denominator position to make it positive. And a little weird thing here, we are left with 4 x's on the bottom. So we will have no x's up top, so we have to fill in that position with a 1. Otherwise, we just have a weird bar with a x to the 4th under it. Kind of strange. So we need that 1 up there to hold that place value. In closing, our first rule says that if I am multiplying exponents with the same base, that I can simply add the exponents together and keep the base. And my second rule, if I am dividing, I'm going to take the exponent from the numerator and subtract the exponent from the denominator. Thank you very much for joining me. Again, my name is Mr. Swaner, and until next time, study strong and keep practicing.